welcome back to another mess of a video. Today we're going to be doing the Elastic Stack, the basics, which is a premium room, just like the other one was. I forgot exactly what it was called. Might be noticing that my voice doesn't sound the best. I'm a bit under the weather, but we move. So let's get started immediately. In this room we will learn how to use, or how the Elastic Stack ELK can be used for log analysis and investigations. Although ELK is not a traditional SIEM, many SOC teams use it like one because of its data searching and visualizing capability. We will explore how the components of ELK and learn how log analysis can be performed through it. We will also explore creating visualizations and dashboards in ELK. This room has the following learning objectives: understand the components and their use, explore different features, learn to search and filter data, investigate VPN logs to identify anomalies. So basically similar to what we did last time. Familiarize with creating visualizations and dashboards in ELK. Let's go ahead and hit that. There's so much to read. I'm so tempted to just turn on my automatic or text-to-speech extension and just have it read everything, because it's tiring to read everything. But anyway, Elastic Stack ELK was originally developed to store, search, and visualize large amounts of data. Organizations use it to monitor application performance and perform search on large data sets. Over time, its features made it popular in security operations as well. Now many SOC teams use ELK almost as a SIEM solution. Elastic Stack is a collection of different open source components that work together to collect data from any source, store and search it, and visualize it in real time. Okay, so that's interesting to know. That's not specifically for cybersecurity, but it can be used for such. I always like those types of tools. So they're not specifically made for cybersecurity, they're not made for, well, basically in general, things that are not made for other things, but you find a way to use them to your, to what you want to use them for, if that makes any sense. Before we go on to learning log analysis through ELK, let's first discuss its core components. So this is the search, this is the stash, Beats, Kibana. Oh, I didn't even know about this one. This must be new. So this is the actual search, this is probably like the database, and this Kibana is probably like the interface or something, that's my guess. And Beats is maybe like the agent, or the forwarder, or like, yeah, that's actually on the host, I don't know. Before we go on to learning log analysis through ELK, let's first discuss its core components. As a SOC analyst, your primary responsibility is to work with ELK to perform log analysis and investigations. You do not need to specialize in how each component behind the ELK works. However, taking a basic understanding of these components is essential. Elasticsearch, aka this one. The first component is a full-text search and analytics engine for JSON formatted documents. It stores, analyzes, and correlates data and supports a RESTful API. I've heard of this RESTful API, but I don't know what it is. What is RESTful API? Let's ask our if I can even highlight it. Let's ask our buddy Echo. Yes, tell me about the RESTful API. What is it? The RESTful API representational state transfer is an architectural style for designing network applications. You use standard HTTP methods like get, post, put, and delete to perform operations on resources in the context of the given text. The RESTful API allows for interaction with the data storage and analysis system, enabling users to retrieve, send, and manipulate data effectively. This means users can perform actions like querying, submitting, updating, and deleting, all via standard web protocols. The use of RESTful APIs is popular to simplicity. Oh, so it's basically just put or update or get, post, Is that it? Yeah, literally just this. And delete. The use of RESTful APIs is popular due to their simplicity, scalability, and stateless nature, which helps in building efficient web services that can handle a large number of requests without storing session information on the server side. Okay, thank you, good sir. You may go now. And supports a RESTful API for interacting with it. Alright, Logstash is a data processing engine. So this Elasticsearch is just a search and analytics engine. Logstash is a data processing engine that takes data from different sources, filters it, and normalizes it. So it has a lot of jobs. It receives data, filters it, and normalizes it to probably a specific format so that it is searchable by the Elasticsearch, I'm guessing. And then send it to the destination, which could be Kibana or a listening port. Listening port. A Logstash configuration file is divided into 3 parts, as shown below. The input part is where the user defines the source from which the data is being ingested. The filter part is where the user specifies the filter options to normalize the log ingested above. So I'm guessing like how you want it to be set up, with like time, IP addresses, date, location. I'm guessing like all those categories, I think. The output part is where the user wants the filtered data to be sent. It can be a listening port, a Kibana interface, or Elasticsearch database, or file. So you can output this into a file, which is cool, but I think we're going to do Kibana. Kibana is cooler. It even sounds cool. Kibana. Sounds like one of those like expensive brands of underwear. Oh no, Dolce and Gabbana. Dolce and Gabbana. Are they even like an underwear thing? I don't know. Logstash supports many input, output, and filter plugins. Input, output, and filter plugins. Input, filter, output. Okay, whatever that means. Beats by Dre. No, just Beats. Beats are host-based. Yeah, so it was host-based. Host-based agents known as data shippers that ship transfer data from the endpoints to Elasticsearch. So basically, it's like a software I'm guessing you install on the devices you have in your network or in your company, the computers, the laptops, whatever, and they send all that data and information that they've collected, and then they send it. Beats sends it to, I believe, Logstash, where it is then processed, whatever processing is. It inputs, it filters, and outputs, then to the Kibana interface. Interesting. Me personally, I would have explained Beats first, then Logstash, because that's usually how the process would go. It would be Beats sends to the actual database, which is Logstash, and then Logstash sends us to Kibana, and then you use Elasticsearch to search whatever you want. So beats are okay. Each beat is a single purpose agent that sends specific data to Elasticsearch. Ooh, what? To Elasticsearch. So it sends it to the search engine. It sends specific data to Elasticsearch. All available beats are shown below. I would guess it would send it to Logstash, no? Because that's like the database, technically. Or it's just a data processing engine. So maybe it's not the database. An analytics engine. Maybe it stores it in Elasticsearch. Maybe it does, I don't know. I was thinking Logstash, because it sounds like how a database would function. Anyway, Kibana is a web-based data visualization tool that works with Elasticsearch to analyze it. So I'm curious, could I install these like just separately? Like if I just want Kibana, could I do that? Or if I just want Elasticsearch, I'm pretty sure we could do that, right? They don't have to necessarily work together. I think they can work separately. But we will be using it together in this lab. It allows users to create multiple visualizations and dashboards. Oh, did I write this? I mean, read this, not write this. is a web-based data visualization tool that works with Elasticsearch to analyze, investigate, and visualize data streams in real time. It allows users to create multiple visualizations and dashboards for better visibility. There's more on Kibana in the following tasks. We haven't even, oh boy. How they work together. Now that we have learned about all the components, let's see how these components work together. Yeah, so it is what I was thinking. Yeah. Well, sort of. I was thinking this one is here, then this one is here. But I guess, yeah. Oh, so Elasticsearch is actually the indexer or the data store. So it actually contains the data. And Logstash is just a process of outputting that data. So it's just the engine of input, then does whatever logic on it, and then output. And then this is actually where it is stored. Okay. And then Kibana accesses the database and whatnot. So beats collect data from multiple agents. For example, WinLog Beat collects Windows event logs and PacketB collects network traffic flows. Logstash collects data from beats, ports, or files, parses, normalizes into field value pairs, so like title, not like title, but like basically categorizes it basically. So like the time, the date, the IP, if I keep using IP, but IP, and maybe country, and maybe like username, whatever information you decide to give them, and stores them into Elasticsearch. Kibana is responsible for displaying and visualizing the data stored in Elasticsearch. The data stored in Elasticsearch can easily be shaped into different visualizations, time charts, infographics, etc. using Kibana. Okay. Logstash is used to visualize the data. Nay, it is this one, which is the Kibana visualization. Elasticstash? What? Elasticstash? What the heck is Elasticstash? What? There's Logstash. There's no Elasticstash. All data apart from JSON. No, it only supports JSON, I believe. Yeah. What the heck is Elasticstash? I think it meant like, yeah, Logstash. It combined Elasticsearch and Logstash. I don't know. Okie dokie. So before proceeding with the following tasks, let's go ahead and start that. We could do the, if I'm too lazy, we could do the attack box, but it's too much lag, I feel like. It's very laggy, even though I'm like decent connection to the internet. It is still very laggy, so I'll just use a VPN. So let's go ahead and read this. The machine takes 2 to 5 minutes. After the machine starts, the ELK instance can be accessed via or by or at this IP. If you're connected with the VPN, if you are connected with the VPN, if you're not, you can use the attack box and access the ELK instance by copying and pasting the machine IP. Use the following credentials for the ELK instance: analyst and password analyst. When you open the ELK instance through this task, each upcoming task will guide you to the features and ask you some questions. These questions will be comfortably answered if you follow along with the tasks. Okay, doke. So we have the IP address. Let me go ahead and connect via VPN, and we'll be right back. Alright, we're back. We're connected to the VPN. We can access the it's probably not up yet. We can try to refresh. Probably gonna take a bit to boot up everything. So let's just remember analyst and analyst 1, 2, 3. Let me copy that just in case. Alright, analyst 1, 2, 3. Okay, it's booting up. It's just gonna take some time. Alrighty. Wow, so much to read. Why is there so much to read? I would have preferred a video. There's a lot to read. From this task onwards, we will discuss Elk's front-end interface, which is the Kibana. These are the main features that a SOC analyst operates on. As discussed in the second task of this room, Kibana is the component of Elk that supports these interactions with the front end. The Discover tab is where the SOC analyst spends most of their time. This tab shows the ingested logs, the search bar, normalized fields, and more. Analysts can search for logs, investigate anomalies, and apply filters based on search terms and time periods. Okay, seems pretty easy. This is just the interface. This is basically just an interface where you could actually interface with it. So it kind of looks a little bit, just a little bit more modern than the Splunk we did last time. So let's briefly see what each element, as highlighted in the above screenshot of the Discover tab, does. If we can see. Okay, so one is the actual logs. Each row shows a single log containing information about the event, along with fields and values found in that log. 2. Fields pane. The left panel of the interface shows a list of fields parsed from the logs. We can click on any field to add to the filter, remove it from the search. Seems easy enough. Index pattern, which is number 3. Each type of log is stored in a different index pattern. We can select the index pattern from which we need the logs. For example, for VPN logs, we'll need to select the index pattern in which the VPN logs are stored. So here, so I'm guessing they're like the data sets, or I don't know, categorized the data. I don't know. Number 4, search bar, simple enough. It's a place where the user adds search queries and applies filters to narrow down the results. In the next task, we will learn how to perform searches through queries. Time filter, we can narrow down the results based on time. Okie dokie. Time interval, number 6. Okay. This shows the event counts over time. Top bar, number 7. Top bar. Okay. This bar contains various options to save the search, open the saved searches, share or save the search, etc. Discover tab, this is the main workspace in Kibana. Okay, we are in Discover tab in that picture. This is the main workspace in Kibana for exploring, searching, and analyzing raw data. 9. Add filter. We can apply filters to specific fields. Okay, to narrow down the results rather than manually typing entry or entire queries. Some of the important elements found in the Discover tab are briefly explained below. Yeah, so I'm guessing the index pattern is like the different data sets or something like that. By default, Kibana requires an index pattern to access the data stored and ingested in Elasticsearch. The index pattern tells Kibana which Elasticsearch data we want to export. Yeah, so it's like, which data set do you want to export? Do you want to export the VPN logs, firewall logs, host logs, a bunch of other stuff. So it's like the index what we did in Splunk, which is like index equals and then the asterisk, which is like everything included in your query. So it's similar to it in that case. Each pattern corresponds to a certain defined. Okay, the index pattern tells Kibana which elastic data we want to explore. Each index pattern corresponds to certain defined properties of the fields. A single index pattern can point to multiple indices. Okay. Each log source has a different log structure. Therefore, when logs are ingested into Elasticsearch, they are first normalized into corresponding fields, values, and values by creating a dedicated index pattern for the data source. In the attached lab, we will explore the index pattern VPN connections which contain the VPN logs. Okay, I understood that. The attached lab will explore the index pattern VPN connections which contain the VPN logs. But I don't understand exactly how they like organize it into different index patterns, because a single index pattern can contain multiple indices, aka multiple logs. This is basically the category of those logs. So yeah, anyway, fields pane. Oh yeah, this looks very similar to I keep forgetting the name, Splunk. The left panel in the Discover tab shows the list of the normalized fields it finds in the available logs. Okay, let me reread that again. The left panel in the Discover tab shows the list of the normalized fields it finds in the available logs. Click on any field and it will show the top 5 values and the percentage of occurrence. We can use these values to apply filters to them. Clicking on the plus button will add a filter to show the logs containing this value, and the minus will add a filter to show the results that do not have this value. Okay, seems easy enough. We can also apply filters to any of the fields shown in the panel on the left. All we have to do is click the add filter option under the search bar, which will allow us to apply filter to the fields shown below. Interesting. Okay, yeah, so the filter and like the search queries are like the same thing. They're basically the filters are there, I think, so you don't have to maybe memorize the syntax of like the search queries, because yeah, you have to like, this is way easier, way more intuitive to just add filter. Maybe, I mean, you can make the case that if you already know the specific query, you could just paste it in instead of like applying 20 filters, but I digress. So, time filter. The time filter allows us to apply a log filter based on the time, so only show me like logs in this day, or from this day to that day, or from this year to that year, or stuff like that. Timeline. Let me read. The time filter allows us to apply a log filter based on time. It has many options. Okay, simple. The timeline pane provides an overview of the number of events that occurred for the time and date as shown below. We can only select the bar to show the logs in that period. The count at the top left displays the number of events found in the specified time. Okay, so like Wednesday or this day or this month, we had a bunch of hits on, I don't know, whatever this day is. January the 16th, right? We had like a bunch of hits over here, and then nothing too much later in the day. And here we had medium, medium, a little bit more here, and so on. This bar is also helpful in identifying the spike in the logs. In the above screenshot, we can see an unusual log spike on the 11th of January 2022. By default, the logs are shown in raw form. We can click on any log and select important fields to create a table showing only those fields. Oh, interesting. This method reduces the noise and makes it more presentable and meaningful. You can also save the table format once it is created. It will then show the same fields every time a user logs into the dashboard. That's interesting. Select the index VPN connections and filter from the... Oh, brother. We completely forgot about it. I believe the username was analyst, if I'm not mistaken. Analyst with a capital A. The password was analyst123. Yay, we're in. Okay, now if we remember how to get there, we have to go to, what was it, Explore? Discover, I think it was Discover. Yes, Discover. Show dates, let's do, can we do everything? All? Okay, or the last year, can we do that? That doesn't do anything. Let's do the last, the last 100 years. The last 100 years. from the 1950s. Oh man, 1950, man, we had a huge DDoS attack in the 1950s. Wait, we had internet, and no, we didn't. I don't think we had internet. 2021. Okay, so I'll say the last 2021, right? So we'll do 2020. What? What is this? Oh boy. Oh boy. Okay, can I just... Oh, brother. End date and time to now relative. Can't I just do like, why is this so complicated? Cause I can't do the last year, cause there's nothing here. Could I do like 5 years ago? Let's do 5. Okay, 5 years ago, 2022. So we have a bunch of counts in here. Alright. And we have the available fields of 15 available fields: ID, index, score, type, timestamp, action, company, index. So a bunch of like I said, IP as well here. Yeah. So we have a bunch of hits here, and we are in the VPN connection data set. Feels fancy saying data set. Basically, just the data that we have that has been organized into the name VPN connections. So let's see what they want. Select the index VPN connection and filter from this. Oh, so we could filter. We were just trying to see everything from all time. From 31st of December 2021. So let's do that from absolute the 31st of December. 31st of December 2021 to the 2nd 2022 to the 2nd of February, I believe, right? 2022. Okay, alright, same thing, just tighter time frame here. Okay, how many hits are returned? The same, 2,861. Right? Yeah. Which IP address has the maximum number of connections? So let's try to do the source IP filter, and we'll see the top 5 values is this dude right here. So let's go ahead and paste bros IP. Which user is responsible for the overall maximum traffic? Okay, so let's see if we can add it to filter, and maybe see the name. Yeah, let's add a username as well to this. Source IP plus. Can't I just? Okay, I think I did something wrong. I want to do like a field thing. Where username, because we don't have a specific username in mind, but just to see the usernames. Oh, that technically lets you see the usernames. Let's see what this is. Rafiq and Suleiman. Okay, let's do this as the... It is a source IP, okay. So which user is responsible for the overall maximum traffic? So the overall maximum traffic was from that IP, was it not? Or we could just go to this and see what this was all about. And username Bentel. Username Simon. Source IP is 107. Well, let's can I go back? Nope, that does not do that. Can I do a Control Z? there's no control Z, but okay, let's do source IP, no? Source IP, and then the most traffic is from this guy. And we just gotta figure out who overall maximum traffic. Okay. So if we filter, so this is the top 5, okay. Filter by this, and then we'll find out whose IP that is. So source 8, and the username is Suleiman. Okay, but this doesn't make any sense though, because if we have the IP, source IP, how do they have the same source IP and different username? Could also be Rafiq or Suleiman. Okay, Rafiq M or Suleiman. Rafiq or Suleiman. They're both using the same username, so you can't really like tell. So let's see the most count in like this day. 96 hits was Suleiman and Rafiq, so it's, you can't even like, I don't know, this, it doesn't even fit. Rafiq, no. So it's like a 3-5 letter word name. For the overall maximum traffic, I don't understand what I don't get it. We can search by username, sure, but like, what is it gonna show me? It says other, so I'm guessing this is like the amount of traffic they've done. Meta filter this, okay. Event time, company, records, other. This is just other. And who is this other? Okay, count. They both have the same, like the same amount. Or Paul maybe has Paul has a little bit more, I guess, than everybody else. So Paul? Would it be Paul? No, it's not Paul. Maybe Paul M? Or Paul K? No, I don't think it's... I do not think it is right. Is there like a specific way that I'm supposed to look at this? So the... Maybe our time is incorrect. 31st of December 2021 to February 2nd, 2022. Okay, that is correct. Which user is responsible for the overall maximum traffic? We don't have, like... Oh, Simon. Why didn't I see that last time? Simon. Okay, but why didn't it show me that here? Like if I go this, it says James is the one with like the most traffic. So is it Simon or is it James? Let's do Simon. Okay, no. Let's do James. Okay, it was James. So why did it show me Simon? What? Is there any way to do a username and then sort by like most traffic? Not really, right? You have to use the, I don't know, maybe like some weird filter. company, source IP, ID, index, action, source state. Yeah, I don't think you have to have like a custom thing to see which username sent out the most traffic. But why didn't I see this? What? This is so weird. This is fine, it doesn't matter. Actually, this is worse. Why would you even have this? Simon did 9% more. This is horrible, horrible graph. I think I prefer this one. Yeah, this doesn't really show me anything. This one is kind of nice, but I prefer the vertical one. This one. So this one is kind of nice. Could I like save this? Add layer, whatever that means. Inspect. What am I inspecting? Inspect what? Oh, inspect the values. Okay. Who is the other? Just random. Alright. Apply filter on the username Amanda, which source IP has max hits. But why does it have different IPs? Like, that doesn't make any sense. One user should have one IP, right? Just my opinion. Source IP equals, oh, this is weird, is greater than, equals exists in any form, requires both arguments. Oh, this is and this is or. Interesting, okay. Just trying to get familiar with this syntax. Oh, what? Why did I say that? Username. I meant to say username, not IP. Username. It's Amanda. Okay, and then see which source IP has max hits. Okay, so let's do a source IP thing as well. Okay, so for Amanda, she has 2 IPs, the top 5 values, but since there aren't 5 or more, I'm guessing she only has 2 IPs. And she has the most traffic coming from this one. But why do you have 2 IPs though? Like, makes it more complicated than it needs to be, I think. This can't be wrong. There's no way this is wrong. If this is wrong, it's loading, but I don't think it's wrong. On 11th of January, which IP caused the spike observed in the time chart? So the huge spike one, right? Okay, let me give it a refresh. Let me give it a refresh. Let's see. Okay, so it didn't even take my answer. But it was correct. Alrighty. On 11th of January, which IP caused the spike observed in the time chart? So that big, huge spike. Let's go ahead and remove this filter. Just regular filter. And this is the 11th. Okay. And which IP caused the spike above? Let's go ahead and look at the... Okay. So 98% of the traffic was from this IP. Okay. How many connections were observed from this IP? What the heck? See if we can copy it fast. Well, it won't let me copy it. That's so weird. Okay, I think I copied it. Source IP. Oh, keep forgetting the simple syntax. That is, or not. Source IP equals this 23136. Oh, right. We're still stuck in the stinking time frame. let's go delete this, and let's go back to our original time frame. Okay, source IP is this. Okay, 96 hits, and also source. Do I have to have a comma or something? Source. How do I separate, like, maybe I'm writing it wrong. Source state. No, this is not and. Or it is and, actually. It is and. And source state. How do I do the thing? How do I do this thing? Source state. Maybe this. Source state New York. Yeah, that's correct, but the way I wrote it is not correct. So let's just do this and then go to source state and then remove New York. But like, how would you do that in this? Oh, whatever. How many connections were observed excluding New York? 48 hits. Okay. Create a table with the fields IP, username, source country, and save. Alright, so let's go to Canvas, dashboard. Create a dashboard. Create a visualization. We want IPs. Separate, I'm guessing, right? Source IP. Just the source IP, the whole thing. Can we get better suggestions? Maybe. These all kind of look weird. Yeah, this is horrible. Why would I even have this? Okay, maybe it's not terrible, but like the coloring is weird. Other 157. I mean, I think you can make the argument that this would kind of help. The other is very weird though. I think I like this. Maybe I think it kind of grew on me in like 2 seconds, because it kind of shows you the time frame too, which is very nice. This really doesn't show you the time frame, it just shows you the amount of records and the IPs and such. This shows you like actually the time and the IP and the amount of records on that specific day. Okay, maybe might go with that. This, no, it's not gonna work. And this looks ugly. This I could also go with this. And this just basically does nothing. So I'll do this, I think. Oh, you can also add things here, can you? Vertical axis, add or drag and drop a field. So yeah, this one has timestamps as well. Okay, so can I... Okay, so how do I add this? What is add? Add a visualization layer. Bar vertical stacked. I'm so confused. What's the difference between this and this? Oh, it's only layer 1. Okay. What? This looks so goofy. We'll remove this because we don't. That's not what I meant by another layer. Okay. So can I save? Save the library? Save and return? Okay, 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 okay. Okay, we're getting the hang of it, sort of. Oh, they want one table. Oh, they want one table. We could just make another one. We could just make another one. So let's do, they want username. Okay, let's add username. IP. Let's add IP. Source country, and that's about it. And source country. Why not? Why can't it just let me add it to the thing? Okay, so we added too complicated. Bar vertical stacked metric. Oh boy, that's too many. Okay, Molina. James from the same IP. Okay, Molina also same IP. Rock. What the heck? Rock from different IPs. Benty from different IPs. James from different. Oh, so these are all the IPs of the different people. And other. Okay, other has like IPs that are not associated to people. Okay. Kind of weird the way they're set up. Source IP. No, that is way weirder. Oh man, this is too much. No, this is way too much. No, I can't even read this. This is crazy. Horizontal axis is the top values of the username. Okay, and then this is the amount of records, and then this is just other. What is this? Bottom axis, left axis, the legend, display, hide the display, show, inside. That looks terrible. Maybe we don't need the thing, like it'll show us. Okay, tab values, right, and then can we create it to something else? Maybe a table? No, table looks disgusting. Metric looks terrible. Area. It's nothing. It's loading, I'm guessing, or empty. Line? Potentially? Line? No, it looks terrible. Tree map? Heat map. Bar horizontal. Yeah, okay, fine. Bar vertical, stacked. Or we can do bar horizontal stacked. What? What the heck is this? It was working well, but... Okay, so we need... Did they say what type of... Create a table. Oh, a table. A table, a table, a table. Okay, so they said a table. I was trying to create graphs and stuff. So IP, so we're gonna need source IP, then username, then the source country. Okay, quite a lot, quite a lot, quite a lot. Top value is Simon with current records. Other from the United States. Other from England. Other from Israel. Other from other. Other. And we have the specific IPs for Simon. But don't they have like different IPs though? Rafik or Molina has no IP. Can we just do not top values, just like the specific IPs? Because it automatically defaults to like top IPs. Okay, can I do this? Number of records too. I think that's automatic. Top values of source IP. Number of values 5. Count of records. Rank by descending. Text alignment, height, column. Oh yeah, there's a lot of stuff to go in here. 10, yeah. There's like a bunch. Did I even do anything, or did I just do nothing? Oh, it does show more. It does show. What if I do, why did it go to 9? What if I do 15? Okay. James, Phil, Jackson, Junijo, Bell, Fawad, Ishmael. It should show everyone, I think, not just the top 5. Group other values is other, maybe not. Just show everything, I think, would be the best. We've quite wasted a lot of time. Okay. Well, let's save to library. Dashboard table. I spent a lot of time on this one. IP, username, country. Country. Tags. No tags, it's too much. Really wasted a lot of time. So I guess we can kind of do this with like, there's a lot of usernames I didn't even check. There's a lot. There's uppercase James, lowercase James. Yeah, different IPs. There's a lot of stuff. So okay, so let's say we're gonna see who has the most traffic. We'll check this. Okay, let's maybe not do that. Can we zoom in? No, we cannot. So this is just the IP. The IP will be like, this IP is 1.7.201.60.19. It'll be like, oh, that's Simon. And Simon has a count of records 277. 275, including this day, where he decided to give us a denial of service. Okay, this, and then like 2 more days here. And then we also have Rafik, 238, and then, oh, okay. So we kind of technically have like a dashboard here, which I kind of like. Might not be the best and organized one, but it works. I think we have like already 30 minutes in. This is gonna be one long video. We can find anything using this option. Let's see how. There is a special language that we can use inside the search bar to perform our searches. It is called KQL, Kibana Query Language. It is a search query language used to search the ingested logs, documents, and Elasticsearch. KQL, the Kibana Query Language, offers a simplified query syntax and supports support for scripted fields. KQL also provides autocomplete. If you turn off KQL, Kibana uses Lucene. Some words I've never heard before. KQL and Lucene. With KQL, we can search for logs in two different ways: free text search or field-based search. Free text search allows users to search for logs based on text only. Okay, that's easy. That's like actually useful. That means a simple search of the term security will return all documents that contain this term, irrespective of the field. Let's search for the text United States, and the search bar will return all logs that contain this term, regardless of the place or field. This search returned 2,304 hits, as shown below. What if we only search for the term United? Do you think it will return any results? It didn't return any results because KQL looks for the whole term word in the documents. Okay. The whole word. Okay. KQL allows the wildcard match to match parts of the word. Let's find out how to use this wildcard in the search query. So anything with United at the end, and then asterisk, so sort of like Linux. We have used the wildcard with the term United to return all the results containing the term United and any other term after it. If we had logs with the term United Nations, it would have returned those as a result of this wildcard. Logical operators and or not. KQL also allows users to utilize logical operators in the search query. Let's look at some examples below. AND operator. Here we will use the AND operator to create a search that returns the logs containing the search terms United States and Virginia. Search query being United States and Virginia. Let's go ahead and try that really quickly. Let's go to Discover. Okay, cancel. Save. Dashboard. Dashboard was saved. Nice. Let's head on over to Discover, and let's go ahead and see what we have here. Let's go ahead and remove all of these, and let's do that search as well. Can I just search like without the quotation marks, like United States? Okay, it does work. And oh, the "and" has to be capitalized. And Virginia. Okay. So you don't have to use the quotation marks, but you probably should. Okay, and Virginia. Okay, or operator. So either Virginia or United States. So you can also select United States and Virginia, but if it's just United States and Florida, it will also give you that. United States and Maine will also give you that because it's United States or Virginia. Okay, United States or England. Yeah, that's probably better. Better, like, so it's less confusing. England. Do we have England? I think we do have England. I probably wrote it wrong. Do we have it though? Source country, England. But like that's 1%. Oops. or England. It is here, but it's probably like we have to scroll all the way down. Yeah, anyway. Not operator. This is the one that I wanted to. Simply, we can use the not operator to remove a particular term from the search term. This search query will allow the logs from the United States, including all states, but ignoring Florida. Okay. Oh, so you have to use the and, not. So, or United States, or what if I do not United States? Does that work? So it'll be England, technically, correct? No, it won't. It'll just show. Oh, okay. So it'll show everything that's not United States. Okay, yeah, so source country Israel, England, 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 England. Okay, so yeah, we'll do that. Give me everything in the United States, and not Florida. Let's do Florida. Everything in the United States, but not Florida. Okay, so Virginia here, South Carolina here, Michigan here, Maine here, Virginia here, Hawaii here, Kentucky, Maine, Tennessee, New York, Maine, Michigan, Kentucky, South Carolina, New York. But what is this? Texas again. It's like the same. Taxes. Tax is tax or is not tax. I made the same joke last video that they didn't spell Texas right. They spelled it taxes. Okay, so we did this in not Florida. So we can use the not operators to remove a particular term from the search results. This search query will show the logs from the United States, including all states, ignoring Florida, or ignoring whatever thing you put in here. It could be Maine, it could be Michigan, it could be literally whatever you want. Field-based search. So this is what we did last time. In the field-based search, we will provide the field name and the value we were looking for in the logs. This search has a special syntax as field value. So it would be something like this, like source underscore IP or whatever, however they set it up as. And see how it has everything here. We'll do this, and then the specific IP here, the whatever the IP is. Blah blah blah. Blah blah blah, blah blah blah, whatever the IP happens to be. Or you could do name, like name equals, or username and colon, and we'll do whatever, we'll do Bobby, and then enter. Oh, my mistake. And we'll do enter, and I'll just, this is basically a field text or field-based search. It uses a colon as a separator between the field and the value. Let's look at a few examples. Search query source IP is blah 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 and username is blah blah blah. Explanation: we are telling Kibana to display all logs in which the field source IP is this and the username is this, as shown below. When we click on the search bar, we are presented with all the available fields that we can use in our search query. Create a search query to filter the logs where source country is the United States and show logs from users James or Albert. Okay. So it wants me to do a source country, so a field thing. Source country is United States. And username equals James or Alberto or Albert. James or Albert. Okay, hit enter on that. We have 161 hits. 161 records. A user Johnny Brown was terminated on the 1st of January 2022. Create a search query to determine how many times the VPN connection was observed after his termination. Interesting. Okay, I think I know how to do this one. So, might have to do date. So, date or event time is greater than he was terminated on the 1st of January 2022. So let's do greater than, just greater than. How do I put the date here? Do they have a specific time? No, they don't. January 2nd, January 1st, 2022. Oh, brother. How did they... Or might just be time. Event time is... Can I do this? Just copy this. Event time and then January. Okay, I just copied this as like a reference thing. Did I even do that correctly? Is greater than expected and or see full error. Can I not do event time? Why would you expect and or? Failed to parse field generate with format. I failed to parse field. So, okay. Filter for value. Oh, so you have to do the at timestamp. At timestamp equals January 5th. No? Expected and or is expects and or because of this at thing. Why is it so weird? January 5th, 2022. Okay, well, it's working, but edit the filter to timestamp. Edit as query. Okay. So the timestamp has to be in like this stupid format. That's so dumb. Can you let me copy this for like 1 second? And whatever this Z is at the end. Okay, let's go ahead and try this out. Timestamp. Let's erase this. Okay, relax. Expected, but found at timestamp. Do we have to do this? Quotation marks. To Y at the end of the input Y, but found colon at timestamp. KQL. Interesting. Okay, let's go back. I mean, I know we can do this like an easier way, but I'm just trying to like test out. Okay, what is a stupid error? Expected and or at the end of white space of the input white space, but found This is so dumb. This is so dumb. Did this work? It worked. What the heck does T mean though? Okay, let's do the. I believe he was on the first. Well, on the 1st of January. So like the very first day of New Year's, they fired this guy. That's crazy. Okay, and VPN log. So about 227. Okay, and username equals Johnny. By the way, this is technically the equals. The colon is basically the equals. Like I keep saying equals, and I like type this in, but this is the equivalent of equals. It's like username is Johnny Brown. So just in case you get confused because I say equals and then I type this thing in, or I select this. Yeah, that is basically the equals. Let's go ahead and hit enter on this, and nothing. Oh, we have to do timestamp is greater than 1 hit. So after he tried it once on the 7th of January to 6 days later, he tried to VPN inside the company. Add for action built, company cyber T event, January VPN log, port 443, protocol TCP, source United States, source IP i7.20.60.191. So from Florida. So he probably tried to and I'm guessing this is like a residential IP. So he probably tried to VPN into the company from his home in Florida. Alrighty. Okay, we already created virtualizations. Wasn't that like one of the tasks, quote unquote tasks? Brother, what the heck? There's too many. There's way too many. This thing it says an hour and 80 minutes, and I mean, I can kind of see why. I mean, we could blaze through this if we wanted to, but the visualization tab allows us to visualize the data in different forms, such as tables, pie charts, bar charts, etc. This visualization task will use the multiple options. Okay, let me redo that. This visualization task will use the multiple options this tab provides to create some simple, presentable visualizations. Create visualizations. There are a few ways to navigate to the visualizations tab. One way is to click on any field in the Discover tab and click on visualizations as shown below. But we will not be going there. We will be going to the dashboard, no? And then create visualization. Okay, so we can do that and then visualize. We can create multiple visualizations by selecting options like tables, pie charts, etc. Correlation option. Often we require creating correlations between multiple fields. Dragging the required fields in the middle will create a correlation tab in the visualization tab. Here we selected the source country as the second field to show a correlation among the client source IP. This is, I don't know, I can't read this. United States, okay, but why would you have it in like this chart? It's so weird. United States is also 71%, but this is other IP, I'm guessing. And then the pink one is like this IP, which is also United States, which is like 3.3% of the whatever. Canada is 9.68%, and it's this blue. But it's so weird. It was that like it's very hard to see the difference between this blue and this blue, or green. Sorry, this like greenish turquoise or whatever color this is, to like this. like a bluish green thing. It's hard to see here, like the specific difference. Me personally, I wouldn't have it like this. We can also create a table. Yeah, I would rather do that. Create a table to show the value of the selected fields as columns as shown below. The most important step in creating these visualizations is saving them. What is saving them? To do so, click on the Save option on the right side and fill in the descriptive values below. Description, title, we did this already. Okay. Steps to take after creating visualizations. Create a visualization and click the Save button at the top right corner. Add the title and description, click Save, and add to the library when it's done. Failed connections attempts visualized. We'll use the knowledge gained above to create a table to show the user and IP address involved in failed attempts. Okay, this is actually an interesting one, which I do see the point of. If you ever want to see like failed VPN, I guess, logins, or how could you even like fail a VPN login? Like, unless you somehow, because it's through a file, or actually no, it could be through a I'm not really sure, but I know OpenVPN is with files, but there could be I think other protocols use like usernames and IPs. So you put in the IP, then you put in the specific username and password, I guess. But yeah, OpenVPN I think is with a file. So I was thinking, like, how do you fail a VPN login if you have the file? I mean, maybe if there's a password, maybe you have the file, but there's also a password and username for that. I think. I don't know. Okay, let's do for failed attempts. Failed attempts. User involved in failed attempts. Okay, but how would you even filter for failed attempts? Let's do a regular discover thing. Server base URL is missing. It should be configured running in production, but some features may not behave correctly. Okay, let's erase this and let's do event. Can we do like an event type? Like failed, like action, yeah, action equals, oh, okay, we do have it, failed, action is failed. I don't want the and, I just want action is failed. And this is, okay, this is the whole year thing. Okay, failed timestamp, this, and this. Okay. So we just have to do an action of failed. So action and failed, and we'll do the visualize thing for it, and this should be the failed. Right, but also add IPs, I think, right? Would be the best option. Huh, so only one IP failed. Can I just do a regular bar or table? Table. Could we do it with, yeah, source IP, and then failed. Count of records metric. Okay, lost. Oh, action failed. Okay, so this is the specific query that we're looking for. Action failed. And what does it want us to do? A table. The table is going to be quite small. is, I mean, does not really have to do, yeah, you don't have to do like the top values, you can do all values. And what did I do? I did something. Source IP, okay. Top values, I don't want just the top values. I want like all the values. Could I do this? I cannot do that. 10? Doesn't matter anyway because there's only one IP, I think. And all of the failed, like, yeah, I think it's only one IP. Which user was with the greatest number of failed attempts? Oh, true. Also, username would be a good thing to add here. Username. Username. Simon. So the IP, username, count records, maybe the date, maybe something else, company, source, country. Nah, I don't think. Simon has the most, or observed in January. Oh, brother. Does it want me to use this as well? Date or time, event time. What if I do this? So just one day, just one day, he had a bunch of 274 attempts all again in one day. 274. I'm pretty sure I did this wrong, but the timestamp. Can I customize time interval? Oh boy, customize time interval. Minimum interval. Huh? No, I mean like event time maybe? Event time. Yeah, no. That, yeah, I'm lost here. Like, can I specifically edit this? Or maybe action failed and like event time is equals, I don't know. Can I save it now? Could I? Yeah. Well, we're gonna do more dashboards apparently. So, wait, what's the difference between a visualization and a dashboard? Is this not like you make the visualization and then you save it? Let's close this. Save, right? I can save and add it to the dashboard. So title will do failed VPN attempts. If I can spell, and then I would just say self-explanatory. No, I'll just leave it as is. Okay, save and go to dashboard. Failed VPN attempts, dashboard table. Yeah, okay, I can see why it's important to label them because I don't even know what I created. Failed VPN attempts, and this is just like, what, like the most traffic. Most traffic created. Okay, and then this is traffic by date. Okay. This is IP, this isn't username. So, yeah. There are a few ways to navigate to the visualization tab. Oh, it's doing something. Oh, we did this already. Creating dashboards. Dashboards provide good visibility into log collection. A user can create multiple dashboards to fulfill a specific need. In this task, we can combine different saved searches and visualizations to create a custom dashboard for VPN log visibility. By now, we have saved a few searches from the Discover tab, created some visualizations, and saved them. We've saved a few searches from the Discover tab, created some visualizations, and saved them. It's time to explore the Dashboard tab and create a custom dashboard. The steps to create a dashboard are: go to Dashboard, click on Create New Dashboard, click on Add from Library, click on the visualizations and save searches. It will be added to the dashboard. Once the items are added, adjust them accordingly as shown below. Don't forget to save the dashboard after completing it. We are basically in the dashboard, but yeah, we should have done like saved searches. So searches done in like the explore thing. Country with TOP traffic. What the heck is this? Country with TOP traffic. With most traffic. Oh, with the top traffic. Oh, I was like, what the heck does TOP mean? So United States, we have the most traffic from the US. Second, Canada. Third, England. Fourth, Israel, France, and other. Okay, I think it's a decent dashboard, I would say. Let's go ahead and save this. Switch to view mode. Full screen. Okay. That's not terrible. I would say that's pretty fine. That's okay. If only they were like live, though. I think they are live, but there's no way to test that now. Okay, we already created it. And I think we're done, yes. Congratulations, we have learned about the Elastic Stack, a widely used tool in the Security Operations Center, SOC. As a SOC analyst, Security Operations Center, analyst, we now understand the working ELK, which is not a traditional SIEM, but is widely used by SOC teams as a SIEM solution. So it's not meant to be a SIEM, but we use it as a SIEM. We explored the key components of ELK, which involves collecting, parsing, searching, and displaying a vast number of logs. We also saw its powerful searching capabilities within logs. We put ourselves in the shoes of a SOC analyst and investigated an organization's VPN logs from within ELK. Lastly, we practiced making visualizations and dashboards within ELK. Organized. Let me read that again because I read it and didn't understand anything what I read. And investigate organizations' VPN logs from within ELK. Lastly, we practiced making visualizations and dashboards within ELK that we did lastly, which gives a single pane of glass for detecting malicious patterns. Yep. So like one dashboard where you can see everything. And that's the room. Let's give it a 10. Submit. Oh, didn't even get to submit it. But yes, finally we finished. I think we have like, this video is going to be like an hour or something. No, probably more, like an hour and 30 minutes. But yeah, thank you for, if you did stick to the end. Thank you for sticking to the end. I'm gonna try doing as many of these as possible. Obviously, I'm not really feeling too great right now, but I'll try to make at least one every day. I have failed for like 3 days because I think the last one was like 3 days ago. So hopefully I can edit it and upload it by today, and then hopefully tomorrow I can continue the grind. And because I'm also technically doing this for everybody else, so they can see the rooms inside TryHackMe. And maybe if you want, you can follow along. If you, it's a little bit difficult, I think, to like install everything because you might not even have the same files as I do. But yeah, maybe some rooms you could follow along. But yeah, that was it for today. So thank you very much for watching and sticking to the end. As always, God bless and take care. Peace.